Hello, Algebra students. Mr. Lawrence here, and today we're going to start learning to solve systems by substitution. Now, I've got two linear equations on here, two systems of linear equations. One is done in blue and one is done in red. I'm not actually giving the equations, but remember, when we solve systems, we tend to find the points. We tended to do problems where the two lines intersected at one point. So the solution to this system of linear equations would be 1, 1, 2, 3, right? The point 1, 3. But there are situations where, the two lines don't have to cross at a nice pretty intersection. Right here, for example, on the red system, we don't know where they cross. We can see where they cross, but we don't know the exact value. Some of you go, well, it's 3 and 8/10. Well, how do you know it's not 3 and 81/100ths for the x-coordinate? One person says this, and how do you know it's not this? Well, it's the same thing. Well, is it? Okay, what if those are only the x-coordinates. What if it's actually 3 and 89, 896 1,000ths? Okay, that's not really the same as 3 and 8/10. It's actually closer to 3 and 9/10, but it's still not the same. So solving systems by graphing is somewhat limited because it's hard to tell exactly where they cross in many situations. Okay, so we're going to learn today how to solve systems by using substitution. Now, it's really easy. It really is. You just have to take your time. Do you remember, I've talked to this, how important an equal sign is? An equal sign is extremely important in mathematics because it openly declares that y is the same as 4x plus 10. These are the same value. Yeah, they are the same value. They don't look the same. They're expressed differently, but they are the same value. And this equal sign tells me that this and this are the same number. They have the same value. Well, remember the transitive property from like first semester? You could say like that A equals B and B equals C, then A equals C. Check this out. What if this is A and this is B and then this is C? If 4x plus 10 equals y and y equals 2x plus 4, can't you say that 4x plus 10 and 2x plus 4 are equal? And now you can solve algebraically. Let's solve for x. You see, before we couldn't solve because we had one equation with two variables. We can't solve this. We can graph the line, which would be the set of all solutions for it, but there's not one solution. But trying to find out where they cross is going to probably have one solution. There are situations where you have no solutions or maybe an infinite number of solutions, but you can't have like 3 solutions. The two lines are either going to cross in one place, they're not going to cross parallel lines, or it's going to be the same line twice, and so therefore they'll cross everywhere. Okay? So let's solve this for x and find out what the x-coordinate equals of where the two lines intersect. So then I'm going to subtract 10 from both sides, and this should be review stuff. 2x equals negative 6, and I'm going to divide by 2, and so x is going to equal negative 3. That's half my solution. I know these lines are going to cross at negative 3 something. And I'll graph this one when I'm done. I'm not going to graph all of them. In fact, while I'm talking here, I'm going to open up my graphing calculator so that it can start working. But anyway, I know the x-coordinate of where they cross is negative 3. Now to get the y-coordinate, I'm going to substitute in negative 3 for x into either equation. It doesn't matter if I do the first one or the second one. I'll usually pick the one that looks like it has friendlier numbers. In this case, they're both pretty friendly, so I'm going to go ahead and put it into the second one. So y is going to equal, what was it, 2x? So 2 times negative 3 plus 4. Well, that means y equals negative 6 plus 4, which equals negative 2. So if I graph these two equations, they're going to cross at the point negative 3, negative 2 if I did my homework right. But let's see, let's bring up Desmos.com. I like that for checking my work on this. Okay, and I'll launch that graphing calculator. And the first equation was y equals 4x plus 10, I believe. Okay, and then the second equation was y equals 2x plus 4. And look at that. Look where they're crossing right there at the point -3, -2, just like I predicted they would using my algebra. Now, this is so much more efficient and effective than solving by graphing. There are situations when it would be better to solve by graphing, if you're doing certain story problems and wanting to know when it's better to hire which company, that kind of thing. But for a problem like this, it's so much easier to do substitution. Okay, now, you don't always have to substitute for y. You don't have to get the y alone. Pay attention to this because some of you will just go, oh, I'm going to always get the y alone. No, that'd be foolish. Look at this system. We've got x plus 3y equals 10, and we've got 4x plus 2y equals 14. Well, that'd be foolish to solve for y, especially in this first equation, because I'm going to get some ugly numbers. I'm going to get 1/3 x. I'm going to get 10/3. Okay, solving for y in this equation isn't too bad. This would be a 2x, there'll be a negative over there, negative 2x, and then be a 7. But look, x is almost alone in the first equation. I am going to take this first equation and I'm going to solve it for x. So I'm going to subtract 3y from both sides, and I'm going to get x equals 10 minus 3y. Now, I'm going to substitute. It looks a little different than this one, but it's the same idea. X is the same as 10 minus 3y. I'm going to take this, and I'm going to put it in for x in the second equation. You cannot put it into the first equation. Why not? Because I solved for x in the first equation. If you do, you're going to end up with an infinitely true statement. Okay? You must substitute into the other equation. So, I'm going to have 4. What's x? Well, x is 10 minus 3y plus 2y, and that's going to equal 14. I'm going to distribute right here. You see how all the things we've been doing this year are coming back. 40 minus 12y plus 2y equals 14. Now, some of you are going to start adding, and you're going to drive me crazy. You're going to drive me crazy. Look, this says negative 12y plus 2y. They're like terms. You don't add, you don't subtract. You combine like terms. You combine like terms. So I'm going to have 40 minus 10y. That's going to equal 14. And I'm going to subtract 40 from both sides. And so I'll get negative 10y equals negative 26. And I'll divide by negative 10. And I'm going to get y equal to positive 2 6/10. And I'm going to go decimal on this one. All right, y is equal, excuse me, to 2 6/10. So in this problem, I ended up finding the y coordinate first. It would be tough to graph 2 6/10 and be accurate with it. Now I have to go and find the x coordinate. Now I have 3 choices in this case. I can take that y value, and I can substitute into the original equation here. Okay, I can substitute it into this equation, or I can substitute it into this equation where x is alone. Often I like to do this one because x is already alone. So I'm going to do x equals 10 minus 3y. So I've got x equals 10 minus 3 times 2 6/10. Well, let me see. 26 times 2, I think it's 78. So x is going to equal 10 minus 7 8/10. Yeah, I'm pretty sure about that. 75. Yeah, that should be right. Okay. And so x must equal 2 2/10. Therefore, the solution to this system would be at the point 2 2/10 and 2 6/10. Which would be difficult to know. You could graph it and see it's about there, but it's going to be tough to know. All right, let's do 2 more examples here real quick. Okay, number 3. Now, What you do on a problem like this is you decide which variable you're going to solve for. I think it would be a poor choice to solve for y in the first equation. Why do I say that? Because I'll have to divide by 6. And if I divide 3 by 6, I get a fraction. If I divide 9 by 6, I get a fraction. I don't want to deal with fractions if I don't have to. All right. Would it be smart to solve for x in this first equation? Well, solving for x would require at some point dividing by 3. Does 3 go in evenly to 6? Sure does. Does 3 go into 9 evenly? Yes, it does. So I might solve for x in this equation. I'm going to consider solving for x in the second equation. Ooh, I don't like it because 9 does not go into 3 evenly. It also does not go into 12 evenly. Maybe I'll solve for y in this equation. Does negative 3 go into 9? Yes, it does. And does negative 3 go into 12? It sure does. I'm going to pick the one that I think would be the least amount of work. So I'm going to solve for x in the first equation because the 3 is positive. In the y in the second equation, 3 is negative. The coefficient is negative, and that might lead to an extra error. So I'm going to rewrite 3x plus 6y equals 9. First thing I'll do is subtract 6y from both sides. I'll get 3x equals 9 minus 6y. Then I'll divide by 3. So x is going to equal 3 minus 2y. All right. There we go. Now x is alone. Now, I must substitute this into the other equation. I'm going to take this 3 minus 2y, and I'm going to put it in for x in the other equation. Don't put it in the one you solve for. You'll end up with an infinitely true statement, okay? Which can happen, but in this case, it's not infinitely true. The lines are not the same line. All right, so I'm going to rewrite that second equation, 9, and then in quantity, I'm going to put the x value, which is 3 minus 2y. 3 minus 2y. Then minus 3y equals 12. I'm just rewriting this equation. Instead of writing x, I'm writing what x is equal to. This is called solving by substitution. I distribute, and I get 27 minus 18y minus 3y equals 12. Time to combine like terms. I got a negative 18y here and a negative 3y, which gets me 27 minus 21y. That equals 12. All right, I'm going to subtract 27 from both sides. And I'm going to get negative 21y, and that equals negative 15. And divide by negative 21, divide by negative 21. Okay, be y will equal, that'll be a positive, and I'm going to divide by 3, and I think I'm going to get 5/7. All right, so now I know the y coordinate of my solution is 5/7. I think the easiest place to substitute would be in this one, because x is already alone. And so I'm going to have x equals, what was it? 3 minus 2y? Yeah, 3 minus 2y. Okay, so 3 minus 2y, and y is 5/7. Okay, now I know that that'll be 3 minus 10/7, and I know that's the same as 3 minus 1 3/7. So when I do that, I'm going to end up with 1 4/7, right? Because 1 and 1 make 2, 3/7 and 4/7 make 1, 2 and 1 make 3. I'm back to where I started. So these two lines will cross at 1 4/7 and 5/7, that point. And that would be almost impossible to graph because the sevens are some form of 0.142857 repeating, depending on which decimal you start with, okay? So it would be impossible to graph those accurately on the graph paper that we use anyway. All right, let's do one more, and then tomorrow in class you will get some practice with this. Okay, so this one here, first thing I need to do is decide which variable to solve for. Looking at the first equation, I don't think I'll solve for x in the first equation because 10 does not go into 5 evenly. I might solve for y in the first equation because 5 goes into 10. 5 also goes into 5. I won't solve for 6 in the second equation because 6 does not go into 5. 6 does not go into 14 evenly. I won't solve for y in the second equation because 5 does not go into 6. 5 does not go into 14 evenly. I know that when I'm solving, I'm going to have to divide by the coefficient on the variable. So I'm making the choice that will give me the prettiest numbers, easiest to work with. So I'm going to solve for y in the first equation. Now it's just coincidence that I've solved for the first equation in every case. That's just a coincidence. You pick the one that will be the least amount of work. So the first step here would be to add 10x to both sides. And then we're going to get 5y is going to equal 5 plus 10x. And then we're going to divide by 5. In all three places, right, we have to distribute. And so then y is going to equal 1 plus 2x. All right, now that I know what y equals, I'm going to substitute it into the other equation. So I write down negative 6x minus 5 times the quantity of y, which is 1 plus 2x. That's got to equal 14. Okay, so I'm going to get negative 6x. Negative 6x. Distribute, not the 5. I got to distribute a negative 5. Be careful. Minus 5x. Oh, don't, just negative 5. Sorry about that. Minus 5. And then minus 10x. That's going to equal 14. Now be careful here. Some of you make this mistake, and I don't know how you're making it. They're on the same side of the equal sign. You just got to combine like terms. Just combine like terms. So I'm going to get a negative 16x minus 5 equals 14. I'm going to add 5 to both sides. I get negative 16x equals 19. Divide by negative 16. Divide by negative 16. And x is going to be real ugly. It's going to be a negative 1 3/16. Now when I go to do my calculations, I'll probably use this number, the negative 9/16. But when I report my answer, I'll use the mixed number because it would make more sense on a graph to me. All right, now again, I've got to decide which equation to substitute it into. I have three choices here. I could substitute it into this equation, or this equation. I'm going to choose this one because y is already alone. So I'm going to have y equals 1 plus 2x. So I'm going to do y equals 1 plus 2. And remember I suggested that I'm going to use the improper fraction form of this. Okay? Wonder Woman's going to make an appearance, and she's going to help me cancel that down. And so now I have 1 minus 19/8. Well, 19/8 would be negative 2 and 3/8, I believe. And now if I take 1 away, or I add 1 to that, I end up with y equaling negative 1 3/8. So these two lines cross at those 2 points, those 2 coordinates, okay? So that's solving systems by substitution. All right, you'll get some practice with this tomorrow. Mr. Laurence signing off. Have a good night, everybody.